Welcome to Serene Science, a place for stress-free learning. Today we're going to focus on stoichiometry problems. The word stoichiometry is really just a fancy word that describes solving chemistry problems that use a balanced chemical equation and some given quantities. If you need stress-free learning on balancing chemical equations, I encourage you to watch my previous video on that. Also, if you need a break from studying, I have a series of guided meditations on this channel that can help you relax and refocus. Check those out if you wish. Now, let's look at a helpful guide that will assist us as we work through stoichiometry problems. First off, notice that lots of relationships have been set up here. So for example, we can go from moles of our substance labeled A to grams of that substance A, or to atoms or molecules or ions of substance A. We can also go from moles of substance A to moles of substance B, and from there we can go to grams of substance B, or atoms, molecules, or ions of substance B. And to make these conversions, we are using conversion factors. And some conversion factors that may look familiar to you would be molar mass. So if you need to review how to calculate molar mass for a substance, I suggest to watch one of my previous videos on that. We're also using Avogadro's number, which states that there are 6.022 times 10 to the 23rd anything in 1 mole of that thing. And a new one may be the mole ratio. So this is another conversion factor, and we get it from the balanced chemical equation, and we will look at that as we solve a problem. So let's go into an actual problem using this nice guide. So this problem asks us how many grams of hydrogen can be produced by reacting 5.00 moles of aluminum with hydrochloric acid, and then the balanced chemical equation is given to us. So first off, we want to know what the problem is saying or asking and how it relates to our balanced equation. And so if I look through the question, I see some substances. I see hydrogen, aluminum, and hydrochloric acid. So I need to be familiar with their formulas in order to relate them to the balanced equation. So hydrogen, its formula would be H2, and it's one of the products in our reaction. Aluminum's formula is Al, and hydrochloric acid has a formula of HCl. So aluminum and hydrochloric acid are our reactants in this problem. And then once we've established that, we can start writing down what we know. So if you don't know where to start with a problem, sometimes just writing what's given or what you know based on the question, the problem, can be really helpful. So some things that we know here, obviously we know the balanced chemical reaction, but we also know that we're reacting 5.00 moles of aluminum. Okay, so those are the two pieces that are given to us, the moles of aluminum and the balanced equation. And then we also want to know what we're solving for. And the problem is asking us for how many grams of hydrogen. So that's what we're solving for, grams of H2 hydrogen. Once we know what we know and we know what we're solving for, we can go down to our nice guide and figure out where we are on that. So we're given, or we know, the moles of aluminum. So that's like our substance A here. So on our guide, we're starting right there, and I'm going to write this down as a plan of attack here. Okay, so 5.00 moles of aluminum, and then from there we can go to moles of any other substance in our balanced equation. Since we're interested in hydrogen, H2, makes sense to go to moles of that substance. So our next step will be moles of H2. And to do that conversion, we use the conversion factor, known as the mole ratio. And once we're in moles of H2, we can go to grams of H2, we could go to atoms, molecules, or ions of H2 as well. But since the problem wants us to solve for grams, our next step will be grams of H2. So we'll be going here on our chart. And to do this conversion, we're going to use the conversion factor of molar mass. Okay, so that is our plan. Next, I'm going to set up a dimensional analysis problem, sometimes referred to as the factor label method. But it's a nice visual way to set up our problem so that our units cancel correctly. Paying attention to units is super helpful when solving stoichiometry problems. So we're going to make sure with any quantity we write out the full units for it. Okay, so we'll start with our 5.00 moles of aluminum. And then I'm going to set up my dimensional analysis problem. And I'm going to go to moles of H2 using the mole ratio. And that mole ratio comes from our balanced chemical equation. And it's going to relate moles of aluminum to moles of H2. And we use the coefficients in this balanced equation to help us. So if we want to solve for moles of H2, we would say 3 moles of H2, and that 3 comes from the 3 in front of H2 in the balanced equation, and we'll say 3 moles of H2 over 2 moles of aluminum, or Al, and that 2 comes from the 2 in front of Al in the balanced equation. When we set up our problem like this, if there's a number, or I will say a unit, that is in the top or the numerator, and it's followed by a conversion factor where that same unit is in the bottom or the denominator, those units cancel. So right now, the unit moles of aluminum have canceled out. Okay, it's because moles of aluminum is on top to start out, and then we're multiplying it by a conversion factor where moles of aluminum is on the bottom or in the denominator. So right now at this point, we're in units of moles of H2. So if I'm following my plan, our next step is to go to grams of H2. And to do that, we use the molar mass. Again, there's a previous video on how to use the periodic table and calculate the molar mass, but for this video, I'm simply going to give it to us. And also recall that molar mass has units of grams over moles, and as a conversion factor that could be flipped around and it could have units of moles over grams as well. But for this problem, since we're solving for grams of H2, that's what we want to end up with, it makes sense to put units of grams on the top and units of moles on the bottom. So the molar mass is going to be 2.02 grams of H2 per 1 mole of H2. Also remember, sometimes we abbreviate moles as just MOL, and that's okay. I didn't forget some letters there. And so then moles of H2 have canceled because it appeared in the top of the one conversion factor and the bottom of the other. So they cancel, and we're left in units of grams of H2. And so now we would plug this into our calculators We have the final unit of grams of H2, which is what we want to solve for. And when we plug this into our calculators, we end up with a value of 15.15 grams of H2. Alright, let's look at another problem. So this question is asking, how many hydrogen molecules can be produced from 2.50 moles of hydrochloric acid reacting with aluminum? So once again, we want to make sure that we understand the substances in the question and how they relate to the balanced equation. So hydrogen, like we saw before, is H2 in our equation. Hydrochloric acid is HCl, and aluminum is Al. Once we've established that, we can write down the information that is known. And so for this problem, we know we have 2.50 moles of hydrochloric acid, HCl. We also know the balanced chemical equation. And then what we're trying to solve for is important to realize. And in this case, we're trying to solve for hydrogen molecules. So molecules of H2. Okay, once we've established what we know or what's given to us and then what we're trying to solve for, we can use our handy guide that's at the bottom left corner. And we want to start by figuring out where we are. In this case, we'll say substance A is HCl since we're given information about it. So we're going to start here at moles of A or moles of HCl. So our plan, moles of HCl. And then once we're in moles of HCl, we can go to moles of another substance, moles of substance B, and since we're solving for hydrogen, it makes sense to go to moles of hydrogen next. And then to do that, we use the mole ratio, and that comes from the balanced chemical equation. After we're in moles of H2, we can go to either grams of H2 or we could go to atoms, molecules, or ions for H2. Well, since we're asked to solve for molecules of H2, it makes sense that our final step here will be to molecules of H2. And to do this conversion, we're going to use Avogadro's number. This is a number you'll want to write down or have in your head, 6.022 times 10 to the 23rd. And it is a conversion factor. We can use it as a conversion factor because it states that there are 6.022 times 10 to the 23rd anything in 1 mole of that thing. So in our case, there's going to be 6.022 times 10 to the 23rd molecules of H2 in 1 mole of H2. Okay. Alright, so we're going to end up right here on our guide. Okay, so let's start putting the problem together. Again, I'm going to use dimensional analysis, also referred to as factor label method, and I'm starting with the moles of HCl. So that's going to be 2.50 moles of our HCl. And then I'm going to multiply that by a conversion factor, and this conversion factor is the mole ratio, which we get from our balanced equation. Again, I'm going to let the units guide me. So I want to get rid of the unit of moles of HCl. And so I'm going to put moles of HCl on the bottom of this ratio. And for HCl, there are 6 moles. So there's going to be 6 moles of HCl, the bottom. And I want to get into units of moles of H2. And so for H2, there's a 3 coefficient in front of it in our equation, our balanced equation. So 3 moles of H2 go on top. And then when we set it up this way, it allows us to cancel out the moles of HCl and leave us in units of moles of H2. Once we're in moles of H2, we'll go to our next and final step. We're going to go to molecules of H2. And to do that, we use Avogadro's number. And again, Avogadro's number tells us that there are 6.022 times 10 to the 23rd molecules of H2 in 1 mole of H2. Okay, that's the conversion factor. Of course, since it's a ratio, it's a conversion factor. We can flip it over if we need to, but in this case, we will leave it as I just wrote it. So we will put the 6.022 times 10 to the 23rd molecules of H2 on the top, and we'll put that over 1 mole of H2 on the bottom. And when we do that, our moles of H2 cancel because moles of H2 was in the numerator, and then we multiplied it by a factor that had moles of H2 in the denominator, so they cancel, and we're left in units of molecules of H2, which is exactly where we want it to be. So next, we'll plug this into our calculators. And what we end up with is a fairly large number, and it would be 7.53 times 10 to the 23rd power, and the units on that would be molecules of H2. And that's our final answer.